Okay, so in this talk, Wilbert and I will give a very brief review of modeling contributions to Arctic research during the previous research plan from the perspective of agency reporting and from the modeling team. Next slide. This review comes with the knowledge that there have been many significant milestones that cannot possibly fit into 10 minutes. So the previous Arctic plan was formulated around 4 policy drivers, and from that, a number of objectives and performance elements were formulated. Next slide, please. So the modeling team sought to document the performance of 2 of these objectives and their related 10 performance elements. These were related to advancing understanding of Arctic processes through modeling and advancing Arctic prediction capabilities. So you can note from these lists here of this basic summary of the performance elements underneath the 2 main objectives that there were several specific projects that were called out in the performance elements. So there were several key projects that were named. Next slide, please. So the modeling team worked to enhance interagency collaboration and identify these developments from the modeling community and connect them to the research plan. So certainly many of these projects, most of these projects, or nearly all of them, occurred independently of IARPC or the modeling sub-team, but we facilitated discussion through our meetings and also connected them with the performance elements for the research plan. So we'd like to thank all of those who made presentations at the modeling sub-team meetings over the past 5 years. They were greatly appreciated. And from these, we're going to highlight approximately 8 research activities that occurred. Next slide, please. Oops. So the first one I'm going to talk about here is the Year of Polar Prediction, which was a significant exercise for NOAA numerical weather prediction. One of the intensive observing periods that was used for YOP occurred as part of Mosaic. Mosaic is the year-long Central Arctic Ocean observing study. It was one of the largest studies ever performed for the Central Arctic, which occurred from 2019 to 2020. The Mosaic Science Plan had its own modeling component to that. From these presentations, we discussed data availability and the targeted processes for these studies, as well as the follow-on modeling projects that resulted from these studies. So in particular here, there were several YOP Mosaic coordinated modeling intercomparison projects, and Marika Holland also presented on PROMIS, the parameterizations for optics, mass, ice, and snow. Next slide, please. So CMIP is a significant effort by the modeling community. There were significant achievements as part of CMIP alone, notably the incorporation of aerosols into cloud microphysical properties. And these have specific importance for the Arctic for representing the supercooled liquid clouds that have been observed in field studies over the Central Arctic. But in addition to the CMIP-6 Earth System Model Intercomparison Project, there were also a set of specific CMIP-approved model intercomparison projects. And we'll hear about one of them, ISMIP-6, later on. But there was also PAMIP, which is the Polar Amplification Model Intercomparison Project, and also SIMIP, which is the CICE Intercomparison Project. There were several intriguing preliminary results that were presented, particularly for SIMIP, indicating that the results were not that dissimilar from CMIP-5, but that there was a higher CO2 sensitivity. So there's some other additional intriguing initial results that were presented as well for these projects. Next slide, please. So seasonal prediction has been an area of significant development over the past 5 years. Incorporation of better physics, resolution, and initial observations were part of these developments. And the investment by agencies into improved seasonal prediction systems and subseasonal to seasonal prediction systems. It has been clear from the recent CICE outlooks that dynamical model predictions have fallen somewhat below the performance of statistical models. So this remains an area of particular interest for IARPC. So that and the performance of the CMIP6 CICE intercomparison project tends to shine a little bit of a spotlight on the CICE component. And that is an area that I think we should take a stronger look at in the next research plan. Next slide, please. So data assimilation and reanalysis. So this was a particular topic for the modeling sub-team. We highlighted two projects. One was Dave Bromwich's Arctic System Reanalysis, and the other one is an ongoing project by NASA known as Polar Mera for the development of improved reanalyses in the Arctic. The use of assimilation in observation system design and assessment was also highlighted. So we had a meeting on observing system simulation experiments, the use of models to produce synthetic observations for inclusion into assimilation systems and to assess how they change the depictions of the Arctic system. So OSSIs and other modeling applications were also highlighted. Next slide, please. And I think this is Wilbert then. Wilbert?
Sure. So we also had a couple of meetings between the modeling team and the marine ecosystem collaboration team to explore the role of modeling into marine biogeochemistry. So one deliverable that came out of these communications was a white paper that was written by Clara Deal and Georgina Gibson, which made some key recommendations on observations, data accessibility, model data integration, and modeling and model initialization. But it also brought home the need for stronger integration between observational and modeling communities, in particular trying to include modeling studies into during the proposal writing process, basically not just as an afterthought. Next slide, please. There was also significant progress made on Arctic variable resolution modeling, and we had one modeling sub-team meeting in July 2020. So very exciting new developments in regional grid refinement capabilities that would allow modeling of the Arctic Earth system in a global context, but with high resolution in the high latitudes where it matters for us, basically. So on the left, we see E3SM Arctic, an Arctic refined configuration of the energy Earth's exascale Earth system model. That's DOE's new climate model, basically, that has an ocean and sea ice grid with 10-kilometer resolution in the Arctic and up to 60-kilometer resolution elsewhere. And on the right, and then the middle panel is an atmosphere land mesh that has been recently created by a project led by Joe Walsh, Zhang Zhang from University of Alaska Fairbanks, in collaboration with Sandia National Lab scientists Erica Rosler and Ben Hillman, and also in collaboration with the HiLab project. And then on the right, we see an Arctic refined configuration of the atmosphere model for CESM2, one that has refinement over the Arctic only, and one that has an additional refinement over the Greenland ice sheet. And it was presented by Colin Jadzicki in July 2020. Next slide, please. Other area where progress has been made is in the modeling of Arctic processes and human interactions. We had a couple of meetings about the interface project, as well as a meeting on integrated ecosystem modeling and a very recent one on oil spill modeling. So the one that I want to highlight is the interface project, which links Earth system model development and analysis, also associated with the E3SM climate model, to multi-sector dynamics, for instance, in the GCAM model. So the interface project wants to address problems related to shipping, fossil resource production, housing and mobility, marine subsystems, and livelihood and health. So this is also very closely linked to the priority areas in the new plan. And next slide, please. So finally, I want to highlight the validation toolkits that have been developed under sponsorship of many different agencies. We had meetings on ILAMP and IOM in 2018, as well as on LiftKit and CMCT, which are evaluation tools for ice sheets. So powerful benchmarking software for the land surface, ocean, and ice sheets, It's kind of trying to address the question, did we build the software that we intended to build? Are we solving the equations correctly? Performance validation, did we build what the users need? And then, of course, uncertainty quantification. How confident can we be in our predictions? And at the bottom, I'm showing two examples of the output from ILAM, the International Land Model Benchmarking Package, and IOM, which is the marine ecosystem version of that. Final slide, please. So to summarize, the agency-funded research has made considerable progress on basic modeling issues for the Arctic, even though progress has not been not totally even among all the priorities that were identified 6 years ago. So more aspects of the Earth system have been implemented in global models. For instance, the Arctic Refined Global Models that I highlighted, and the explicit links to human dimension. There was a significant development in the process modeling and the individual components. Examples are ice sheets that will be addressed by Sophie. CICE will be addressed by Elizabeth, but also marine biogeochemistry and basically all the other modeling components. And as Richard highlighted, significant progress has been made in the development of subseasonal to seasonal forecasting systems and reanalysis. So even though the modeling community makes significant progress, there's still a lot of work to do, and that is kind of the role for the next Arctic research plan. I just want to highlight one upcoming meeting on March 16th, where we will be addressing the implementation plan for the monitoring, observation, modeling, and prediction foundational activity. So this is where we can brainstorm about what the modeling community wants to accomplish in the next phase. So with that, I'll hand it off to Elizabeth.
Thank you, Richard and Wilbert. And while Elizabeth gets her slides set up, I'll just remind people that you can put questions or comments in the chat at any time, and then we'll hold on to them until the Q&A at the end. And Elizabeth, we see your slides.
Okay, great. All right, so I'm Elizabeth Hunke. I'm a CICE modeler at Los Alamos National Laboratory. And among other things, I'm the lead developer of the CICE model. And that model is used extensively by the climate and Earth system research groups. It's used for climate and polar process studies and also by operational forecasting centers. And I would say that CICE is not just a model anymore. It's kind of become a whole CICE modeling framework. And it is now managed by the CICE Consortium, which I lead. So this modeling framework promotes global collaboration. It unites research developers with operational users. And we all have a common goal, which is to accelerate scientific research and development for CICE models, and thus to strengthen our forecasting capabilities. And so this talk highlights the CICE Consortium's unique paradigm for community modeling. And in the next several slides, I will highlight who the institutional consortium members are and how they are using the model. So I work for the Department of Energy, and DOE incorporates the column physics from CICE, which is called ICEPAC, into its energy exascale Earth system model. Then the National Science Foundation supports community climate research using CICE within the community Earth system model. And CESM is developed by the National Center for Atmospheric Research, as well as many other contributors. The Danish Meteorological Institute uses the CICE sea ice model as part of a coupled ocean sea ice prediction system. And that is driven by meteorological data from ECMWF, European Center for Medium Range Weather Forecasts. Then we have Environment and Climate Change Canada, which uses CICE to forecast conditions in the Arctic Ocean as well as in its marginal seas. And these predictions include landfast ice. And that's a new modeling capability that the Canadians contributed to the CICE model. Then coupling CICE with the ocean and atmospheric models, the US Navy produces predictions of the ice and then submits the output data to NOAA and to the US National Ice Center. And both of those organizations incorporate the data into their forecasts. And NOAA is now incorporating CICE directly into the National Weather Service's numerical weather prediction models. And they're doing that in order to better capture the large-scale influences of sea ice on global weather patterns. IOPAN is the Institute of Oceanology at the Polish Academy of Sciences, and they work with the Naval Postgraduate School to produce 6-month forecasts for the Pan-Arctic and several subregions. They're doing this using the Regional Arctic System Model, which is RASM, and of course, RASM does use CICE. And then the newest institutional member of the consortium is NASA. And NASA will further engage with the CICE community for improved data model comparisons as well as climate modeling research. And then there are many other universities and modeling centers that contribute to the code base. In 2021, the consortium won an R&D 100 award for software and services. That's research and development, top 100 innovations, I guess. And we also won their Gold Special Recognition Award for corporate social responsibility. And I'm especially proud of that one because it honors organizational efforts to be a greater corporate member of society. Now, the CICE development platform resides on GitHub, but the consortium framework is much bigger than that. We operate in the context of the larger CICE modeling community, and we assist with integration of new model developments. We review code and documentation. We help with testing the code and the modifications, and we also provide updated model releases. All of the code, whether it is formally released or not, is available for scientific testing and use by the modeling community. And the community's subsequent developments are incorporated back into the consortium's repositories for everyone to use. Now, the consortium's member institutions provide in-kind contributions of their staff's time to support the consortium's goals. The consortium incorporates intellectual property protection within an open software development framework. And our governance mechanisms include a sponsors group of agency level program managers and an executive oversight board. Now, these two groups provide resources and oversight to ensure that the consortium continues to benefit the CICE user community as well as the agents themselves. Now, a little bit about the code. There have been many additions and modifications to the code over the past several years. One of the biggest changes is the advent of ICEPAC. That contains all of the CICE model column physics, by which I mean that's everything that acts within a single vertical column or a grid cell in the model. And now ICEPAC resides in its own code repository separate from the rest of the CICE model. And we've done that so that modeling centers that only need to use the column physics can use it more easily. Some major additions to ICEPAC include a flow size distribution and a new snow model. And then one thing we're planning to do over the next year or two is to develop a benchmarking and Lagrangian simulation suite for ICEPAC, which is based on Mosaic and other data. Then a major effort over the past several months has been development of a C-grid option for the dynamics model in CICE. It's always been on a B-grid, and what I mean by B or C grid, that simply defines where certain quantities like velocities and stresses are located in a grid cell. And that definition really affects the equation discretizations. So many modeling centers have been asking for a C-grid capability in CICE, which they expect to improve the coupling with C-grid ocean models. And so we set up a working group, and we've held a couple of coding camps to help make that happen. CICE's supporting infrastructure includes documentation, it includes clean coding standards, thorough test suites, and also an automated workflow. And this infrastructure and testing is a significant part of the reason for the code's usability and also versatility in both climate research and short-term forecasting. And then in support of the community, we developed and held a tutorial right before the pandemic lockdown. This is the last time a lot of us saw each other. And we are now planning another user workshop for later this year. We do have many other plans, both long and short term, and we generally take things as they come. That's because the consortium is essentially a volunteer organization where various agencies are volunteering their staff to participate. So our institutional members contribute new capabilities as a result of their programmatic responsibilities at their own agencies. But then they're doing that while also helping university and other users in the broader community to use and develop the model themselves. And so that's a very quick overview of the CICE Consortium, and I'd be happy to take questions, or we can move on. I think Liz said we weren't going to take questions in between, so as you wish.
Thank you, Elizabeth. Yes, we'll hold questions until the end so we can do them all at once. And so thank you very much for an excellent presentation. And then Sophie, if you'd like to get your slides ready to go.
Absolutely. Share screen. There you go. You see my message screen. I had promised myself I was going to clean it just for you guys, but I never had time. Thank you for inviting me to give you a very worldwide overview about ice sheet modeling for ice sheet model intercomparison project for CMIP6 is MIP6. As you can see, this is one of the figures of photos of one of our workshops. It's an amazing group of scientists that has been together for many, many years. And that timeline that I show on top is messy in purpose. It kind of depicts some of the key aspects that we did throughout the start. Generally, the little stars are workshops, and then the triangles are also workshops. And then big arrows were key deadlines or key deliverables. And then the lines underneath were things that happened. I will not be able to give any justice to what MIP6 has done. I will focus really right now only for Greenland standalone ice sheet simulations, but there is much, much more. Right, so how did we start? MIP6 started in July 2014 with a workshop organized at NASA Goddard Space Flight Center. It was sponsored primarily by NASA, but also CLIC from it's the climate and cryosphere effort of the WCRP, which really kind of encouraged to put the European modeling community in the sense of ICE2C and the ice sheet modeling community in the form of CICE in the same room so that we could devise a protocol to deliver better projections of sea level rise. It became an adventure that resulted in so much in my mind. Of course, I'm really biased, but never mind. What did we do in terms of some of the aspects of what we did? Those dotted lines are all of the work that some of our members did in order to help with the protocol. So for example, the red line for over 2.5 years, some key members really worried about how do we select CMIP models to do our projections, and how do we also transfer those CMIP climate models into forcing that are related that an ice sheet modeler can use. So that's, for example, this red line as part of the model, MIP6 model evaluation and forcing group. Then the green line, for example, is an example here about we had another team that also really thought about how do we improve aspects that we know that ice models can't really do very well. So a key one, of course, is ice ocean interparameterizations. And so again, some folks for over 3 years or more kind of thought carefully about how we can improve those parameterizations. Actually, you can see I can't count anymore. It is 4 years. But anyway, it resulted in, for the green ice sheets, 2 types of parameterizations, which are shown in green. I will not go into the detail. I won't have the time to do justice, but it's basically 2 very different types of parameterizations for implementing ice-ocean interactions in Greenland so that ice sheet modelers could actually try to do a projection. We have a special issue in the cryosphere where we have a lot of the key papers for ISMIP6, so I will encourage you to kind of go there. And you also have to think in terms of background that ISMIP6 was also, you know, we were because we wanted to, we were working on a tight, weird schedule because we wanted to deliver projections to be taken into account for IPCC AR6, which therefore had to have any publication submitted by December 2019. And we also wanted to have simulations for ice sheet models driven by the new class of CIMIP6 projections and climate models, which were running behind schedule. So you have to think about, in addition to how do we force models better, how do we implement ice-ocean interaction better, how do we do all of those things, how do we variables names that didn't exist into CIMIP6, there was nothing before CIMIP6 started really for capturing better land ice. At the same time, those CIMIP6 models were running late. So we got ourselves squished into this very narrow timeline to deliver a framework and a projections. So it's just now to kind of think about what we managed to do. This is an example of the Greenland ice sheet model that took part for the standalone aspect. I call it a zoo of ice sheet models because it's basically, but it's not because it kind of takes into the participation of any ice sheet model in the world. It's very international and anybody who wanted to take part could take part. You can see that they're very different in terms of numerics, physics, initializations, how they do surface mass balance, how they do velocities. So they are very, very distinct. I also wanted to point out actually that so many of our participant members with those little stars are actually, so 6 out of the 14 participating Greenland models are from folks in researchers at universities and at federal labs in the US. So there's a huge representations. And then if you don't have, you also recognize some of the names if you squeeze a bit more. So for example, ISSM might be, it's developed at JPL, but it might be also run, for example, in Germany. Or PISM, which is developed at University of Alaska, might also be run in a different place. So VUB, it's New Zealand, right? So so the US modeling community has actually much more of an impact than we can think of. And so in addition, what this table does not reflect is, of course, all of the folks that worked on developing the protocols and the forcing and the parameterizations. And so in a group papers, usually we have over 40 international institutions listed. So what is behind our projections? Well, it's a zoo of ice sheet models that are forced by selected CIMIP models that is then emulated because the issue that we faced is that you know, ice sheet models take a long time to run, and so we can only do selected simulations. But really, we want to kind of cover a whole range of future climate, especially if we want to kind of give something that's useful for the IPCC. And so that's what we did with the emulation part. In terms of IPCC, how did ISMIP6 contribute? Well, it was actually key. This is one of the figures of the IPCC chapter 9, where it kind of shows for the projection for the Greenland ice sheets, the ISMIP6 raw simulation versus the emulator runs. But you also have to take into account that, of course, this is how I'm talking as an IPCC author right now, is that you had to assess, the IPCC report is, of course, ISMIP 6 by a lot, but it's not only ISMIP 6. And so we have this comment in the text kind of saying these projections, as well as those from AR5 and the SROCs, are lower than the study of Ashland et al. 2019, and the range from structure expected citation, Lambert et al. Continue to contribute to the deep uncertainty project sea level. So that's a key point to remember, that even though ISMIP 6 was a key contributor to IPCC AR6, it had to also include other studies. Now, in terms of future sea level, the range that ISMIP 6 projects is slightly narrower in range than the AR5 and the SROCs, but the median is the same. But what is in a way quite amazing that we don't realize is that really, if you look into the details of the methods of previous assessment report, ISMIP 6 allowed for the first time to have actually Greenland projections dynamical component due to ice sheet models. In previous assessment report, the dynamics, for example, here for the SROC was linked to a quadratic function of time. So, of course, what I like about ISMIP 6 is that we also revealed certain aspects that we need to move forward on as a community. This is an example of one of those and what we are working on right now. Ice sheet models, for example, are much better at capturing present day compared to previous effort like sea rise, but reproducing the historical run is very, very hard for ice sheet model to do that. This is what I'm showing in that plot that was published in the community paper, where we are struggling to reproduce a good historical simulation, within gray being the observations. And then the same study also showed that, well, how are you going to start evaluating the model? Because if you pick your favorite observations, you might get a different answer. And so those are the kind of questions that we are starting to address as a community, and that will be very key to ISMIP 6 follow-on effort. Of course, the problem is that, for example, the kind of question we're thinking right now is that, yeah, you can try to reproduce the historical run better, but then in order to do that, maybe you need to also know better the historical climate forcing, and that's non-trivial. The box in blue here that I'm showing with the spread in ISMIP 6 ice sheet model is basically the same box here as the spread of Greenland surface mass balance, the Greenland SMB MIP intercomparison for MIS SMB. So those are questions that we'll have to address as communities. Since I know that I'm short in time, I really wanted to kind of spend time with that slide. In summary, if I think back about all that we've done with ISMIP 6, we have been very successful in linking the CMIP and the ice sheet modeling communities. Before that, the climate modeling communities would not really care too much about the polar climate that they would deliver for the ice sheets. We had to do additional research about ocean and atmospheric forcing for our ice sheet models, and of course, those will lead to improvement in the future. The sea level projections that we delivered on time were based on dynamic ice sheet models, and that's a big, big deal when you think about it. Okay, they might be dealt, I mean, we had to do the emulators and all of those things because some of the CMIP 6 models were late, but we still managed to deliver that. A framework allowed for the uncertainty in sea level to be explored, including CMIP 6 variables in the data request for the CMIP 6 data request. That took a long time to kind of get this protocol done. And then it is also allowed for the first results for interactively coupled ice sheet within a IPCC class assistant model with NCAR, for example, having done simulations of ice sheet models coupled to their climate models in terms of projections. So I highlighted some of my participants, the whole community. And so with that, I will say thank you to all of them, and I will stop screen sharing so that we can go on for questions.
Thank you so much, Sophie, and thank you to all of our presenters for really excellent presentations and for all of the work you've done over the last many years on modeling in the Arctic. As a reminder to folks, if you have questions, you can do one of two things. One, you can put it in the chat. You can either chat everyone, or if you prefer to be more anonymous, you can send a chat message directly to me with your question. Or you can use that raise hand function that if you click the little smiley face with the plus, the reactions button on your Zoom toolbar, you'll be able to then raise your hand, and that'll let us know that you need to unmute. And I'll start us off. I did get a pair of questions via the chat for Richard and Wilbert. So for Richard, what are the results of global snow validation? And to Wilbert, do validation toolkits and bioactivities on the whole pay sufficient attention to terrestrial snow cover?
I'm not sure what the global snow validation results have been. I don't think I'm familiar with that. Wilbert, do you recall that?
No, I don't, sorry.
I think there has been a tremendous research effort gone into improving the representation of snow in surface models. In particular, several groups have been involved in improving snow albedo and aerosol deposition onto snow surfaces. And that's been particularly important for Greenland, but also for other locations as well for improving the snow mass balance. That plus there's been a lot of focus on the energy conductivity of snow over sea ice surfaces. And that's been a recurring theme for the sea ice models.
Thank you, Richard.
What was the second question?
It was, do validation toolkits and bioactivities on the whole pay sufficient attention to terrestrial snow cover?
Sorry, if they pay attention to terrestrial snow cover?
Do they pay sufficient attention? Yes.
I think the snow cover is part of the ILAM package, but I'm not too familiar with that in detail to see how it functions, how it's being represented. So, but that's something that might be willing to follow up with Forrest Hoffman and see if there are any ILAM publications that have emerged from the CMIP6 exercise.
While we wait for other questions to come in, I would love to hear from all of you where you think Arctic modeling and the models that you work on are heading in the next few years. Yes. Richard.
So I think we're well aware that the new research plan has much more of an emphasis on indigenous impacts in Alaska. And so I think we need to move our focus more simply from the Earth system models to the risk projection, risk mitigation, sustainability issues, and things like that. And so I think those are certainly areas that are on our radar for the next plan. We've had a recent meeting on composition forecasting, and that leads into topics like forest fires and air quality and community sustainability and risk management associated with air quality. And I think that'll be important as well. I do think that in the past research plan, the ice sheet model development was novel. I don't think that there has been, well, there have been intercomparison studies in the past. I don't think that they put the ice sheet models together in the way that they have previously. And so I think that's a novel result. And I think that that also goes to risk mitigation and risk assessment in terms of sea level rise for Arctic communities.
Thanks, Richard.
To me, the role of modeling is really in the integration part. So, I mean, you can do observations and on specific Earth system components, basically, but it's really through the modeling that allows you to bring everything together and put it into a kind of a predictive form, so that we can try to anticipate what might be happening in the future. So to me, the prediction and the integration of different sources of information is one of the key elements of modeling going forward. I'm pretty sure there are many other opinions around, so if you have so many thoughts that you want to share, then please unmute yourself. I see that Larry has his hand up.
Larry, you're muted.
I apologize. You think I'd learn after the last couple of years, wouldn't you? So I don't have an opinion on that, Wilbert. Thank you. I just have another similar question in that it's just amazing to me how the modeling capability has advanced over the last 5 years and just incredibly over the last 10 years. So I'm just looking forward to the next 5 years. So this new Arctic research plan is really focused on the higher level questions about, pulling all the basic understanding of basic research and the various disciplines together to address some of the higher level societal level questions. And so I'm curious, these systems models are really showing remarkable capabilities. Do you think in 5 years, do you think we'll be able to take on the questions like modeling issues of societal importance, like coastal erosion or I don't know, ice road construction or those other issues that are important to communities?
Sophie, I see you nodding. Do you want to speak to that?
Well, yeah, I think so. I think it's you are seeing more and more in my community being forced to think differently on whether what we're delivering is of relevance to the users. And one of those questions is basically, well, yes, but sea level, especially if you look, yeah, the Greenland and Antarctic ice sheets, they might be the most uncertain aspect, but then in the coming decades, they're not the most important aspect of sea level rise in the US. It will be things like land sinking and movement. And so more and more, those kind of processes are going to have to be included either in actually coupled models or afterwards. So synthetic, afterwards. So like, for example, the NASA Sea Level Change team is worried about those kind of things. How do you add, we're developing a framework that is trying to add this better component of the land. The other question I think that we're also realizing too is that outlet glaciers around Greenland and Antarctica might react much more, peripheral glaciers. They might be much more sensitive to climate change than we think of, and we tend to ice sheet models that those regions are maybe modeled more by both, and it will be the source of future sea level rise much more. Those might be both modeled by glaciers community and ice sheet communities. And then how do we then make sure that it's actually no double counting? And that there's a question that we're asking as a community. If you think about way forward and what we are moving into, how do we make sure that we are also modeling the right things and not forgetting to model certain aspects is very important. I think also the movement of people is going to start being included in climate models too. That's my dream.
That might actually be a great segue into another question that I've gotten into the chat through the chat, which, given the successes in the past 5 years and including community interest in modeling and the next 5-year plan intent to include impacts on Indigenous communities, how can social science researchers best contribute to modeling efforts?
Well, I think it would be useful for social scientists to review reports such as the IPCC report and things like that, and to begin a bridge between the scientific results and the social sciences, and to see where we can have application and things like that. So I think it's important to begin a dialogue between the communities.
Wilbert, you'd also come off mute. Do you want to add to that?
No, I think Richard is right. I mean, there is obviously a a gap between those kind of modeling and the Earth system modeling that we are on our side the most familiar with. So there needs to be the dialogue in trying to build the understanding about what one modeling community can do and what the other modeling community can do and how you can bring that together. I think the efforts like what's being done under Interface and ICOM is another coastal project are a step in the right direction in that sense, where Earth system modeling is really going to be trying to inform human decision making, for instance. Maybe Elizabeth, she's co-lead of the ICOM project, which is, as I said, another DOE coastal project. And do you want to add something to that, Elizabeth?
Well, I guess I could. Yeah, the ICOM and Interface both are integrating elements from different program areas within DOE, where, you know, in some of the program areas, there's a very strong focus on Earth system modeling, and in others, there's a focus on the societal impacts part of that. They call it multi-sector dynamics. And so these projects are figuring out how to, well, a couple of things, how to use results from one area in the other area, or alternatively, how to couple them directly. And that's a much bigger challenge. But so those projects are just kind of exploring the space and seeing what can be done in that context. But I wanted to add one other comment here, and this is from the perspective of the CICE Consortium. I totally agree that we need to expand and open the dialogue among these different communities, but it's more than just talking. I think we need to get them actually working together. And that's part of what makes the consortium work well, is that we have this multi-step process where, you know, we have modelers who are focused on the models, and then we have people at the other end of the pipeline that are actually doing the predictions and getting it out, you know, talking to the stakeholders and figuring out how to disseminate that information. And there's a whole pipeline, many steps there, going from one to the other. And I think that is a gap in a lot of modeling activities. And how do you actually interface with the stakeholder community? The modelers themselves aren't necessarily going to do that directly, and we need to set up that pipeline.
Thank you, Elizabeth. I think we have time for one more question if anyone wants to drop it in the chat or raise their hand. And seeing no questions, I will remind folks that there is a full report coming out. Hopefully you'll see it this week, that's highlighting all of the different accomplishments of the last 5 years with IARPC and the Arctic Research Plan. So keep an eye out for that. It will include information about modeling, but also about observations and connecting research to human needs. And we hope that you all enjoy it. I will also remind folks that if you're not yet a member of IARPC Collaborations, you can sign up. We would love to see you on the site, and you can be involved in future modeling collaboration team meetings, as well as other teams on the website. And then finally, I will say a huge thank you to all of our presenters and to all of you for joining us today. So this has been recorded and it will be posted on the IARPC Collaborations website by the end of the week.
Thanks very much.
Thank you, everyone.
Thanks. Bye-bye.